Hi, I'm Bob Henry with Epilog Laser. We're joining you today from the factory here in Golden, Colorado. Thanks for taking some time to be with us. Fiber laser technology is fast becoming the ideal choice for companies that need convenient and cost-effective marking solutions. As marking regulations become more prevalent across many industries, today's manufacturers, designers, and engineers are taking a closer look at bringing marking technology in-house. Not only are laser marking systems an invaluable tool to help strengthen identification processes, but when brought in-house, these systems can help increase traceability, improve quality control processes, and even help with branding efforts. With today's presentation, we're going to demonstrate marking on a variety of different materials using our fiber-based laser systems, the FiberMark and our new FiberMark Fusion Laser system. Along the way, we'll demonstrate how easy it is to set up a laser job, and we'll talk about key features of the FiberMark and FiberMark Fusion systems that make laser processing very convenient and user-friendly. With that, just a brief introduction to the systems. Our FiberMark unit, 24-inch by 12-inch work area with an approximate 7-inch Z-drop. We've had this system on the market for about 7 years. Very popular for marking applications with our industrial customers. And our new product, the FiberMark Fusion. We're really excited about this system. Much larger work area, 32 by 20 with a 13-inch Z-drop. We're going to show you the materials briefly now that we're going to be working on with today's demonstration, and then after that we're going to get started with marking. Before we get started actually marking on the materials, I wanted to give you a brief tour of the materials that we're going to be using today. On the table you'll see a variety of things. I'll explain briefly what these are. First, we're going to mark on some straight old stainless steel. This is actually an ice skate blade. This is a very common type of material that our customers use. Second, we're going to move to an anodized aluminum material. Again, a very common material that's used for marking with our laser systems. We'll then use this 4140 stainless steel black oxide coated. This is a CNC tool holder. Many of our customers like to brand or mark their products, and so we're going to put a logo on this as well. We'll show you how to make that a nice bright whitish mark to get really nice contrast there. We're then going to move into some raw aluminum here, and we're going to show you in software how you can set this up to optimize the marking time, and we'll go into a little bit more detail on that. We're going to run all 6 of those pieces in one job, and we'll show you how that works quite well. Over here we've got a typical jig setup. Many of our customers will use a jig similar to this. They'll fixture their parts in place in the jig, and then they'll set up the graphic image or the artwork relative to that image and mark all those parts at one time. With this, we're going to show you a slightly different marking technique as well. Most of the things we're going to be doing today we call raster marking. With these tags, we're going to be doing what we call vector marking to increase the speed of the mark. We're also going to mark on some plastic material. We have some polystyrol and some ABS material here. These mark up quite nicely with the fiber wavelength laser. And the last thing we'll show you will be some cylindrical marking on brass using our Rotary device. So with that, let's get started marking. Okay, let's get started with marking on material. Recall that we're using, for this first demonstration, the stainless steel ice skate blade. First, I'll draw your attention to the computer. We're using CorelDRAW here. We've got the Easton logo set up that we're going to mark on this skate blade. Regarding software, I want to point out that Epilog laser systems are compatible with a wide variety of software programs. We're using CorelDRAW today, but you can use a variety, again, of software programs. AutoCAD is popular, EngraveLab or SignLab. Adobe Illustrator is often used as well. For barcode applications, Bartender or Label Matrix is oftentimes used. But again, for today, we're going to be using CorelDRAW. So once we've created the graphic image, I'm going to go to the print driver. So I'll click on the print icon, and then I'll pull up the print driver for the Fusion Laser system. In the print driver, you'll see that we've got a variety of different settings that we can work with here. First, I'll talk about the laser type. We're using the fiber laser as opposed to a CO2 laser today. We're going to be doing a raster mark on the skate blade as well, so I'll select raster here. Autofocus is a great feature. I'll show you that with a later demonstration. Generally, I just want to show you kind of the highlights of the driver here. we're going to select a speed, a power, and a frequency value that we like for this particular material. So with stainless steel, I'm going to select maybe 19% speed, 100% power, and then a frequency value of 1. Right now, we're ready to print the job, send the job over to the laser, so I just click on OK. And then I hit print, and the job goes over to the laser. While we're here, I'm going to talk a little bit about the Epilog Control Center. The Control Center is a fantastic tool. It's actually a program that you load onto your laser, or I'm sorry, onto your computer. It gives you full functionality of the laser right at the computer. With older technology, you had to send the job over to the laser and then do all the manipulation of the controls of the laser at the laser. But here with the Fusion Laser, we can do it both at the laser system and in the control center. One of the neatest features, you'll notice here we have this job list, and it gives us an estimated job time to do that particular job. So that Easton logo on that material is going to take us an estimated 30 seconds. Of course, this is an invaluable tool for customers that want to estimate a job before they actually run it and determine how to cost that particular job. You'll see a lot of other settings in here. This is just general information about how the laser is set up, how it's configured. You can change speed and power as well here at the Epilog Control Center. But I wanted to show you this. Again, we're going to do some more work in here a little bit later, but this is a wonderful tool. So when we're done here, we can simply minimize that. Now we're going to move over to the laser and actually set up the material for marking. Recall, again, we've sent the job over, so now we just need to fixture the material for the marking process. You'll notice that we've got this focus gauge in the laser system. This hangs here. We also have the capability with this laser to do autofocus, and I'll show you how that works based on material thickness with some of the material that we're going to be working on in a minute. So you'll notice again that the skate blade is quite a bit lower than that focus gauge. We need the focus gauge to be touching off on the material to have the right focal distance. So on the control panel of the laser, I'm going to use the up and down arrows to go to the focus button, and I'm going to raise the table up. And you'll notice that we've got fairly fast movement here. With the Fusion Laser, we can select fine or coarse movements to allow for really fine-tuned focus adjustments with the laser system. So I use both of those, coarse and fine, to get the right focal plane, the right focal distance, I should say. Once we've got that, we can take this off, and then we'll just put our material anywhere on the table. What we're showing you here is great for prototyping. This is wonderful for doing one-off or figuring out a particular material, the laser parameters that work well for it. So again, a good prototyping function that we're doing here. When we get into some of the other materials, I'm going to talk more about batch layout, where you can fill up the entire bed of the laser and then have the laser mark all of those at one time. So back to the control panel, we've got the focus set. I'm now going to go to the jog button on the control panel. And when I've selected the jog button, using the joystick, I can move the lens assembly anywhere I want on this table. And you'll notice that red dot pointer there. That's a visual indicator as to where the marking location is going to start. I want to mark roughly in this area right here, that spot being the upper left corner of the page where I'm going to be marking, or rather of the graphic. So once I got that location where I like it, on the joystick on the control panel of the laser, I'll select it, I'll press it once to set a new home position. You'll notice that the lens assembly moved just slightly there, locking into place. We're now ready to actually mark. So I'm going to close the lid, and we'll start this job. To start the job, I simply press the go button on the control panel of the laser. You'll notice with the FiberMark Fusion Laser and our standard FiberMark laser that we have this green tinted Lexan material. There's an organic dye in here that absorbs this light energy, so they're fully safe. Of course, Epilog builds all of our laser systems according to all federal regulations. We're required to provide interlocks on these systems so the laser beam can escape. So once the job is complete, we get a beep tone, we open up the door, and then you'll notice that we've got a nice mark on that stainless steel. Now let's move on to the next material. The next material that we're going to work with is anodized aluminum. This is black anodized. Nice material here. Very common material to use with fiber laser system marking applications. Remember the last job, we set a new home position. For this particular graphic, or this mark here, we're going to set the 0, 0 position up in the upper left corner here relative to this location here. We're not going to change the home position. But because we've already changed that position, I need to go to the jog button on the control panel and then restore the original home position. And you'll see by selecting restore at the jog function on the control panel, we now have our 0, 0 position back at the origin point. You'll also notice that we'll need to change the focus a little bit. So back to the focus button on the control panel, I'm going to lower the table using the coarse feature until I have enough clearance to put on the manual focus gauge. And then I simply raise the table back up, get it close, and then I'm going to switch over to fine focus, bring the table up just a little bit more until it touches on the material, and there we go. Remove this, put it back up in the upper left corner there, and we're ready to mark. At the software side, we've built a graphic image. This is a corporate logo with a barcode and identifier built in. So we're going to again go back to the print driver here. We're going to go to the preferences. Once we've selected the driver we want, again we're using a fiber, we're doing raster work. For this material, we're going to run at a much higher speed and a lower power and a higher frequency. If we were to use the same values, laser parameter values that we used on the stainless steel, we would darken this aluminum quite a bit. What we want to accomplish with this anodized is to make a nice bright white mark. So we're going to decrease the power relative to speed. Of course, the speed goes very high, and we're increasing the frequency as well, which will produce less discoloration, less ablation of the material. So once we've got those parameters set, we just click OK. We print the job over to the laser. Job printing is very quick, almost instantaneous. The job's already there. We're ready to go. Now, one thing that I want to point out is that with the anodized aluminum material, oftentimes you can get a whiter type of mark by changing the focus slightly. Normally, you're going to focus at a 0 location using the focus gauge, but what I want to do with this anodized aluminum is change the focus maybe about 40 to 50 thousandths of an inch to produce maybe a whiter type of mark. So I'm going to set a 0 focus here, and then on the display panel I can very easily see how much I'm moving, and then I'm just about 41 thousandths of an inch there. I like that location, and so now I'm ready to mark. Remember that we've got the job at the laser. We've changed the focus just slightly by about 40 thousandths of an inch. We'll close the lid and we'll press the go button. This will start the marking process, and you'll see that we're marking on the material. You'll notice this is a pretty quick marking application here. Again, at the high speed that we're running, this is going to be a very fast mark. Normally our customers will gang up as many parts as they can in the laser system instead of just doing one at a time, and I'll show you some of that application as well with a different material. So once the mark is complete, you'll see that we've got a nice whitish mark on that material. The next material that we're going to work with is 4140 stainless steel. This is a tool holder used in CNC machining applications. Oftentimes our customers like to produce a brand on there, a logo perhaps, maybe a serial number. With this particular piece, we're going to put a whitish type of mark on here. Again, with the laser, we could run this so it's a very dark mark with ablation of the material, but we were looking for a little bit more contrast, so we're going to do sort of a whitish kind of mark on here. With this sample though, I want to show you the autofocus feature that's built into the FiberMark Fusion. What I'll do is measure the height of the object that we're going to mark. And you'll see that this is about 1.24 in size. So I'm going to program that into the print driver. Once I've measured that, I can put the material in place, again in the upper left corner. At the computer, I've got the logo that we're going to run for this particular job. Again, go to the print driver for the laser system. It's a fiber laser. Here, I want to select autofocus. You'll see that I've got autofocus here, and then I can change this focus value. This value is the height of that material. We're essentially telling the laser we want the table to move up a certain distance to produce the kind of mark that we're looking for. So let's change this to 1.24, the height of the material, and we're ready to go at this point. Let's see, those parameters look good. Again, we're going to do a higher speed mark, we're going to use less power, and a higher frequency. So once we've got those set, we click OK, and then we'll print that job over to the laser. Let's take a look at the Epilog Control Center and see how long it's estimated this job is going to take here. So let's bring this up. The Control Center, you'll see that we have these labeled. We've got black oxide. That's estimated to take 1 minute and 11 seconds to run. The last job we just did on the anodized aluminum was right at 30 seconds. So very handy, again, to estimate the jobs before you run them over to the system. We'll take a look at that, and we'll minimize this. We're ready to go. So let's move this over just a little bit, actually, this graphic. I'm going to send this over to the left slightly, because we want to mark more on the end of that tool there. Once I've changed that graphic, I do need to resend that, so I'm going to go back into Preferences, double check everything, looks good, click OK, and then Print, and then this new job is sent over to the laser system. So you'll notice when I close the lid and we start this job that the table is going to come up automatically to that pre-measured, that predetermined distance where we're in the right focal plane. So I'll close the door and press the Go button, and here we go. You'll see the table come up, and it's going to go right to where it needs to go based on the measurement that we provided, and then the marking starts. Again, this is a fairly high speed mark. We put a fairly large graphic on here for you to take a look at. Normally in production setting, people are going to try to minimize the amount of marking they're doing, maybe a smaller logo, maybe just a part number, something like that. But we wanted to demonstrate the marking quality here as well as the capabilities with this logo. With this mark, we're actually not ablating the material. We're removing the coloring from the black oxide to expose the color of the subsurface metal. That's what gives us the nice contrast. This is what a lot of our customers are looking for, is to produce that kind of contrast. And this is almost done here. Okay, job is done. Again, we're just running one sample here. In a production setting, our customers are going to load up the entire 32 by 20 workspace of these particular parts and have the laser mark them all at the same time. So I'll tip this towards the camera a little bit so you can see how bright that mark is there. Let's move on to the next material. Our next material is machined aluminum. These are parts that we actually manufacture here at Epilog. So we're going to set these up in an array here. I've got the artwork already set up, but I want to show you how you can do multiples on the laser. But more importantly, we're going to use what we call a color mapping technique, where we can essentially define how we want the order of the marking to happen. Normally, if we're marking along all these parts, the lens assembly is going to travel left and right across the entire field. What we're doing here is, because we're putting a very small mark on here, we've got a lot of space between the marking fields. We call that white space. Running a laser across a lot of white space takes time. So we're going to color map and tell the laser that we want to mark this piece, and then that one, and then down the line. So once we've got the part set up in the laser, let's turn our attention to the computer where we've got this graphic image already set up. So you'll see on the page here, we've got a 32-inch by 20-inch page. That's the size of the workspace in the laser. These rectangles here, of course, correspond to each of those individual parts. Those are pre-measured, so we know those sizes. I'm going to zoom in on this a little bit here and show you some of the more detail in these colors. You'll notice that we've got these small marks. We've got a red, a green, as we scroll across, blue, cyan, magenta, and yellow. So in the print driver, we will go there now, and I'll show you how we've set this job up to accommodate marking those parts individually. So again, just go to the print icon, select the driver that we're looking for, go to selection here. Again, back to the general tab. We're not going to use autofocus here, so we're going to deselect that. We're using the fiber laser. This is a raster job. Everything looks good there. What we want to do, though, is go to the color mapping tab, and here we're going to set all the parameters for this particular job. We're also going to do an autofocus feature here as opposed to using the manual. Let me explain. So for each of these colors, we've established a speed and a power and a frequency and a focus value, the focus value being the height of that part off of the table. Sometimes if you're working with different materials, you may want to have a different type of effect or a different type of mark on the same material. You can color map that and use different laser parameters to get those different types of marks. Here we want all of the same type of mark, so we're using the exact same laser parameters. We're running this at 17 speed, 100 power, and 1 frequency. But again, the important point here is that we're telling the laser that we want each of those individual graphics to be run by themselves instead of taking more time to engrave all of those objects at the same time. So once we've done there, or once we're done there, we click the OK button, and the job gets sent over to the laser. Click on print. Let's double check that Epilog Control Center and see what it's telling us that it's going to take to do that job. It's about 54 seconds to do that job. Again, job time estimator here tells us what it's going to take to do that. Another cool feature of the Epilog Control Center, I'm going to close the lid here, is that I can start the job right at the control center. I don't need to push the button at the laser, so I'm going to start that job right here. I'm going to press the go button. You'll see the table comes up and the marking starts. Here you'll notice again that we're doing one part and then moving over to the second part and then all the way down the line. Again, this is a big time savings on a lot of materials where there's white space, a lot of white space between the marking objects. All right, our job is done. And we've got all of those parts marked in a nice array there. You'll notice that aluminum is difficult to get a real dark contrasting mark. You can get a dark gray, but you typically never get a black mark on a raw aluminum material. But you'll notice here, difficult to see perhaps, but we've got a very nice clear mark. Let's move on to the next material. The next material that we need to mark is stainless steel. These are small tags that might be used in an industrial marking or coating process. You'll notice that we've got a fixture here that we're putting the tags into. This is common for our customers to use this type of fixturing device. This is actually built for our smaller 24x12 format laser, but it gives you a great idea as to how you can build a fixture to accommodate a variety of different shape parts, different size parts. So what we're going to do is to focus on this material. Back to the control panel on the laser, we'll go to the focus button, we'll hang the focus gauge on, and then raise the table up until it engages on the material. Again, we're using macro focus here, and I know that that tag is the exact same height as the bed, so I can just go to micro here, raise up a little bit more until we touch off on the material, and we're ready to go. I'll take the focus gauge off and make sure that all of my parts are fixtured in here correctly. Oh, that one was off a little bit. Always better to double check your parts before you run the job. So we've set up the laser, we're focused, we've got multiples in there. Let's go over to the computer where we have the actual graphic image set up. So you'll see that we've got a page outline here that corresponds to 24x12, the size of the fixture or the jig that we're using. In there we have some smaller circles, of course rectangles that would correspond to the size of the actual tags that we're working on. I'm going to zoom in on that just a little bit so you can see what those look like in a little bit more detail. So here we've got single line fonts. We're going to do, instead of raster marking, which is what we've done to this point, this time we're going to do vector marking. It's going to be a higher speed type of mark, more like a plotter as opposed to a printer. So once we get this job set up, we simply will select the items that we want to run, select them there. Actually, I'm going to do this rather. I'm going to select these objects, and then independently I'm going to select the different rows that I want to run. So I'm capturing all of those graphic elements there. And then again, back to the print driver and then to the ECC. So we bring up the print driver. We will, let me back out just a little bit here. You'll notice here I need to do selection because I selected just some objects to run there. So in the driver I want to select that. You'll notice if I deselect that, it will do all of those. Rather, I want to, here we go, back to selection, and I just want to capture those. So back to the preferences. With this particular job, again, it's a fiber job. It's in vector mode. Before, recall, we were running jobs or controlling jobs in the raster settings. Because this is a vector job, we are going to use these parameters here. So we're going to run at 30 speed, 100 power, 1 frequency on this job. We're not going to select autofocus because we did a manual focus here. Everything looks good with this. I'm going to click OK and then print. Before we actually run the job, let's go back to the Epilog Control Center and take a look at what's going on in there. Here we go. There's our dog tag jig setup. Looks like it's going to take about 1:22 to run this job. Everything looks good here, so we're good to go. I'm going to close the lid, and then again I can start this job at the control center without actually having to push a button on the laser. So I'll start the job here, and you'll notice that the motion is quite a bit different. Instead of the left and right printer type of motion, we're tracing specific line segments with this single line font. This is a quicker marking application in many respects. Kind of depends on what you're doing, the size of the graphic and the material that you're working on, but this is a very common application that many of our customers use for higher speed type of marking. You'll notice that this is sparking a little bit. We're using a 30-watt laser here. I should tell you that Epilog offers the FiberMark and the FiberMark Fusion Laser in 10, 20, 30, or 50-watt options. We're using the 30-watt with this. More power, more output from the laser tube effectively results in faster processing. You can get the same types of marks with all of those wattages. You can just do it more quickly with a higher wattage laser. So here we're working on the third row now. This is what we would call ablation, where we're removing metal material to create an impression or an engraving into the material with some depth. Almost done here, one more tag. And you'll notice on the control center that while the job is running, we have the engraver status in the upper right corner, which is red, indicating that the job is running. Now it turns to green, indicating that the job is ready, or the laser is ready to accept another job. So we'll open the door here, and you'll notice that we've got some real nice dark marks, single line marks on that material. All right, we're ready to move on to the next material. The next material that we're going to work with is copper-clad CR4 circuit board material. Many of our customers like to use their FiberMark lasers to do prototyping of circuitry on this material. So we've set up a kind of a simple circuit. We're going to show you how we can ablate the copper from the FR4 material. And so I'm going to put this up in the upper left corner of the table, the 0, position, and we'll start our work from there. I'm not going to manually focus here because I've measured the thickness of this material at 62 thousandths of an inch in thickness. And so at the computer, I'll establish an autofocus value for that thickness, so the autofocus will be done automatically for us. So here's our graphic image on the computer. This is just kind of a simple circuit design that we put together. I'm actually going to move this graphic over just a little bit so it kind of hangs off the edge of that circuit board, something like that. And then I'll select that object and go back to the print driver. We'll go to selection. And again, fiber laser autofocus, we want to use that. Looks like I've already set the 62,000 focus for this. Because we're ablating a fair amount of material, all of that copper from the FR4 material, I'm going to run this at a speed of 12, power 100, and then a low frequency value. Once I'm done with my settings here, I go to OK and print. Now this job will take a little bit longer than a standard job because where you see black on the screen, the laser is going to remove all of that material, leaving the white traces that you see intact. Let's go to the Epilog Control Center and see how long this job is estimated to take. Looks like this is just going to be under 3 minutes to run this job. That looks good to me. Let's close the lid. And again, we'll start the job from the control center here. I've got the job they want, the circuit board copper, and then I click on the start button, and again you'll notice the table will come up to the right focal distance before the engraving or the marking starts. So this left and right motion again is what we call a raster marking here. With this material, we're actually removing or ablating the copper from the circuit board material to just leave those traces exposed. Just a few things at the control center here. I can pause a job here. I could do it at the laser, but I could also do it here by clicking on the pause button. I could then resume that job by hitting start again. Again, really handy feature. The Epilog Control Center that you see on screen here gives total control over the laser at the computer. While that job is running, I'm going to give you just a brief tour of the other functions in the control center here. So we've run a bunch of jobs. You'll see they're all stacked up in here. It gives you the job time to run those particular jobs. Great again for our customers who want to estimate how long a particular job is going to take. Simply build the job in the graphic, send it over to the laser, and then in the control center you can see how long it's going to take to do that job. We talked about the engraver status here. This red indicates that the job is running. If we pause it, it'll turn yellow. If we resume it, again, red. And then when we're ready for another job to run, the status indicator, or the engraver status rather, turns green. You'll also get the state telling us it's running. Let's go take a look at some of these other functions in here. For instance, the control tab. This is a great feature here. This is more of an advanced type of feature where you can set the Z height on the table. You can home from this location. We've done all of these things at the control panel on the laser, but again, you can do them all here. We've also done jogging by using the joystick to run the laser around. You can do those things here. Also, I'll point out that you've got an engraving status bar here. This green bar at the bottom of the page is an indicator of the progress of the marking. Let's go to the configuration tab here. This is where you want to set up all of the parameters for a job, or rather all the parameters for the laser. For instance, we've got a firmware version, serial number on the laser, table size is specified. The IP address, I should point out that all Epilog lasers can run off of a USB connection or an Ethernet connection. Networking is really nice for our industrial customers because it allows them to run a variety of laser systems from one computer, or they can run one laser system from any network computer. So IP address is specified for this output device. This gives general information about the system settings, the home position, the rotary home, the table home, stuff like that. Okay, the job is done. Let's go back to the job status here. So 2 minutes and 56 seconds to run that job. It's now complete. And you'll notice it looks like we've got some good ablation on that material. I'm just going to wipe some of this off with my thumb here. You'll notice that debris comes off. This might require a little bit better cleaning than just my thumb here, but you'll notice we've got a really nice circuit board trace created through ablation of that copper on the FR4. Next up, we're going to work on some plastic material and transition over to our 24 by 12 format FiberMark laser. As I mentioned, we're going to transition over to our FiberMark laser system. This is a system that has a 24-inch by 12-inch work area with an approximate 7-inch Z-stroke in it. This is a machine that we've had on the market for over 7 years. Fantastic device used for many, many different types of applications. We're going to do some plastic marking in here, and then we're going to use our rotary in this FiberMark laser as well. But let's start with this polystyrol material. So we've got the laser set up, we've got the material in the machine. Let's take a look at the graphic image here. You'll notice we've got just a basic graphic set up. We're ready to go with that. So I'm going to go to the print driver. I'll go to preferences. And you'll notice that in the general settings here, we've got a combined job. We want raster. The size of this piece is not the right size for what we want to do with the laser. So what I'm going to use is a feature in here called job save or configurations. So once you've found the parameters, the size for a particular job, you can save that in the print driver. That actually saves it out to the hard drive on your computer, and then you can recall that at a later time. You'll see that I've got a couple different files in here. So I'm going to select PolyFM. I'm going to click on load, and all of the settings for that particular material then are populated in the general tab of the driver. You'll notice that the speed changed from 50 to 60. The power went from 50. The frequency changed as well, and it's just a raster job. Also, the piece size now equals the size of the item that we're going to be marking on. So with that, we're ready to print. I just click on OK and then print, and the job is sent over to the laser. At the laser, I'm going to use the focus gauge, and I'm going to hit the focus button. I'll hang the focus gauge on the lens assembly, and then I'll simply raise the table until it touches on the gauge. This laser, like the FiberMark Fusion, has a macro and micro focus. So I bring the table up using the macro focus to get it up close, and then I'll use the micro focus to touch off on the material to find the right focal distance. That looks good right there. I'll hit the reset button. Our job is in queue, and we're ready to mark. Again, I close the lid and press the go button, and we're marking. Plastics are really interesting with this wavelength of light. We find that many of these engineered plastics mark beautifully with this wavelength. There are some materials that work really well, some not quite so well. At Epilog, we can test your material in our applications lab and help you to define if it's going to work well for your material or not. But again, that was 26 seconds to mark this particular polystyrol material, and you'll see we've got a really nice black on white contrasting mark there. The next material we're going to mark is an ABS polycarbonate material. This has got a brownish color, a brownish tint to it. We're just going to keep going here with marking. I'm going to use a little wedge here because this is not perfectly flat. I'm going to use this to prop this up just a little bit so we've got a nice flat marking field here. There's some things I want to show you with this particular application that are really useful. First thing I'm going to do is hit the focus button and lower the table down quite a bit. I'll hang the focus gauge on the lens assembly, and at the control panel on the laser, I'm going to select XY off and then the go button. Once I've done that, I've disabled the axis. I can drag the lens assembly wherever I want on the part, and then I can focus up to get the focus gauge touching on the material to get the correct focal distance. Perfect. I'll also use the red dot pointer, so I'll turn that on here with this button, and you'll see that we've got a nice red dot. The red spot is going to be the center of the graphic that we're going to mark on this material. Once I've found the proper location, at the control panel on the laser, I hit the Set Home button. That will lock the servo motors in place, and that will now become the center of our marking field. Going back to the computer, we'll pull up that graphic file that we're going to use for that job. There it is. And you'll notice that it's just a simple lot number. We're going to go to the print driver again, go to the Preferences tab, And then we've got some presets that we've already defined. So again, go to the Advanced tab. Oh, looks like we need to load those. Actually, instead of loading those and going through that process again, I'm just going to set up this job as if we were starting fresh. So on this particular material, I know that we can run at a high speed, a little bit lower power. So I'm going to go to, say, 40 power on this one and 100 frequency. If I set the frequency very low, it might produce some charring, or we might get a lot of foaming of the material. So I'll keep the frequency high, the speed high, and the power sort of moderate. And so here I want to point this out. This center function, recall that at the laser we disabled the axis, we set a new home position. In order for the laser to recognize that home position, I use this feature here, center. I can select the center of the object to be at that red spot on the laser, or the page, or the left, or the top. Here I want to use center. So once I've got all the parameters set, I hit the OK button, and then the print button, and then the job again is sent over to the laser. Close the lid, press the Go button, and we're marking. "16 seconds for that mark, and that's a nice big mark. Very nice contrast on there. The next item we're going to mark is a cylinder using our rotary attachment. So we'll get that set up now. The last marking that we're going to do today is a cylinder. We're going to use a brass cylinder roughly 3/4 inch in diameter. To mark around the circumference of an object, we use our rotary device. This is one of many rotaries that we offer. This is a 3-jaw chuck rotary with an idle side centering device. Let's install this in the laser system now, and then we'll get this set up to run. So this just drops in here. There's some pre-drilled holes in the table that fixture in the rotary right in place. We'll also plug this in over here, sending power and electronics to the rotary device, and then we'll turn it on. So you'll notice when the rotary is installed, the x-axis, or the axis of the beam, will come out center line over the rotary. We can disable the axes and move them out of the way, X, Y off, and the Go button. Now we want to take our brass tube here. Let's measure it just to make sure that we have the right diameter on that. And you'll see that it's just about 7.5 inches in diameter. This is important because we need to program the rotary to spin at a certain rate relative to that diameter. So the first thing we'll do is fixture it in place here with the 3-jaw, and we'll slide the idle side support mechanism over so we've got a nice level plane to mark on. The next thing we want to do is at the rotary itself program in 0.75, which will be 0.75 inches diameter. There we go, 0.75. So now the rotary has been programmed to accept this diameter and spin at the appropriate rate. The next thing we want to do is to set the focus. Again, we'll use our focus gauge. I'm going to lower the table a little bit, bring the lens assembly over, and then bring the table back up until the material touches on the focus gauge. Perfect. Now with the red diode pointer on, which I actuate from the control panel, I'm going to set my mark right there. And then at the control panel on the laser, I'll hit set home. That's my new home position. We're ready to mark now. At the computer, you see I've got just a basic graphic set up here. We're going to go to File, Print again, bring up the print driver. For this job, again, fiber, we're not going to use autofocus. Oh, let me back out here. I'm actually selected the wrong driver. So you'll notice in this print dialog box, there's a number of different drivers that we can select. We're running a variety of lasers from this, so I need to make sure that I'm directing my job to the right output device or the right laser. So here I'm going to select the FiberMark, I'm going to go to raster. I'm going to center, but I want that graphic to start on the left where the red dot is. So I'm going to select left center here. And with any kind of hard material like this, I'm going to set the frequency fairly low, high power, and a little bit slower marking speed. We'll go say around 20% speed. And then once that's done, I click OK and print, and then the job goes over to the laser. Again, we'll close the door and run the job. You notice the rotary device spun the cylinder back to the top of the graphic, and it's actually marking, the rotary's spinning the part, so we're marking around the circumference of it. With this particular rotary, we can accommodate up to 6-inch diameter parts. And the length of the parts that we can put in here, approximately 10 inches as well. The rotary that you see in here, we sell just as you see it, and then we have a bag of accessories as well, different clamping mechanisms on both sides that allow you to grab onto larger items. And we're done. Job will beep. Let's move that out of the way again, and you'll see we've got a nice mark on there. There's always a little bit of laser dust, material dust that comes off, so we're going to wipe that off. You'll see we've got a nice bladed mark into that brass material. Simply loosen the 3-jaw, slide the idle side support mechanism over, and again we've got a nice mark that goes around the circumference of that tube. That concludes our demonstration today. We ran through a variety of materials, different types of coatings, different shapes, different sizes. I trust you have a good sense of the capabilities of the laser system to work with those types of materials. We'd love to talk to you if you have a particular material you'd like us to process. We can do that in our applications lab. We're available online, of course, toll-free. Give us a call. We'd love to talk to you. Until next time, thank you.